Hi, hello. My name is Maria Rodriguez-Martinez. I'm the technical leader of systems biology at IBM in Russlikon in Switzerland. And I'm the technical coordinator of the European project iPC, which is a very ambitious consortium that includes 21 partners from 3 different continents: Europe, the US, and Australia. So I'm the technical coordinator of iPC. That means I'm the person in charge of making sure that partners can, we achieve the goals that were promised when we wrote this grant proposal, but also to make sure that partners can cooperatively work with each other. We have all the means of communicating and collaborating and make sure that collaboration is efficient and happens as planned. The goal of iPC is to produce new technologies for the stratification and the clinical treatment of children with cancer. We have 5 targeted cancers as the focus of our research. Specifically, we are looking at hepatoblastoma, medulloblastoma, neuroblastoma, leukemias, and Ewing sarcoma. These are 5 of the most common childhood cancers, and they are the leads of mortality in children, in pediatric cancers. Our consortium includes both computational partners that have a deep expertise on the analysis of molecular data and clinical data, but also clinicians who are experts on the research and clinical management of these diseases, and also biologists and experimentalists who can produce new technology, to apply new technologies for the production of cutting-edge data that we can use to build our models. And about the models we try to produce, our consortium is based on the idea of developing a virtual patient. What is a virtual patient? This is a virtual avatar that represents a patient, in our case, a child. So we cannot do experimental trials on a child. We cannot take this child and give them 100 different experimental drug treatments and see which one works better. But we can create a model, a computational model that resembles this child, that has the same molecular features, that it gathers all the information that we have about this child, and we can use this computational model to treat in silico different drug combinations, these targeted therapies, immunotherapies, and eventually come to the conclusion of what is the best treatment for this child. And eventually this prediction can be applied to this child in a safe manner. So we know that this is the optimal treatment that maximizes positive outcomes and reduces side effects. So to achieve this goal, we have many computational partners in this consortium. We have experts on both cloud implementation to make sure that all data will be easily available and distributed and accessible to all computational partners, to make sure that all the models developed are also accessible to partners in the consortium, but also to the whole scientific community, and to make sure that everything that we produce is reusable and available to the community according to the FAIR principles. Challenges, we have different difficult challenges. At the level of the data production, so the data availability, we have a challenge to have enough data to develop our models. For instance, although we have clinicians in our consortium that are the lead experts on each one of these cancers, pediatric cancers are still fortunately not very common, and then we have a limited availability of samples. For instance, just to give you an example, hepatoblastoma, although it's a leading cause of childhood mortality, still we don't have a huge number of samples because there are not so many samples profiled worldwide. So in order to overcome this challenge, we are really trying to put our best effort to gather all available data sets that are publicly available, and also to produce, when necessary, data available to our consortium for the development of our models. A second challenge will be also the integration of the models. We have partners that are experienced in different types of modeling, and each one of them produces informative information about different data types. In order to make a prediction that is useful for the patient, we need to put together all these models and all these predictions. That is challenging because these models are not designed to be together, so we'll need to have efforts to kind of homogenize and put all these models together into a virtual patient that indeed predicts clinical useful things for the patient.